Hi, I'm Christina, and welcome to the first of my cancer translation videos. I work in cancer clinical research, and I've worked in cancer clinical research for the better part of 16 years now. And I know that doctors and PAs and nurses and all of us that work in clinical care have our own language that we use when we speak to each other. And it's important that we use that language with each other. But sometimes when we speak with patients and family members, we forget to back off a little on that medical jargon and speak in a way that might be a little easier for the average person to understand. And so a lot of times over the years, I've spent some time with friends and family members trying to translate what may have been told to them by doctors or healthcare providers into just layman's terms so that they really understand what's going on with their cancer or their cancer treatment. And so I thought maybe I could do some videos like that for just the general public, because cancer is pretty prevalent in our society these days. And I think it's good for people to understand what's going on with their bodies and their treatment if they're having to go through this, or even if you just know someone who's going through something like this. So the goal of these videos is to take just some basic concepts about cancer and cancer treatment and things surrounding that and take them out of that clinical medical jargon, that take them out of that scientific terminology that you may hear or read somewhere else, and break it down into simple, easy to understand terms that pretty much hopefully anyone can understand. So this is the first video, and the first video is just what is cancer and a little bit about what causes cancer. So let's get started. Okay. So let's start with the basic definition of cancer. So the most fundamental definition of cancer is it's a group of cells that are dividing rapidly and out of control. And if they're not stopped, they'll take over the whole body. That's it. That's the most basic definition of cancer. So how do we get that? Well, what happens is we start with what I call a clerical error. I'm gonna write that up there. Number one, the first step is a clerical error in your body. Important because that means you can't catch cancer from somebody else. It starts in your body in one of your cells that up until this point has been normal. Now, don't go out somewhere and say, I went on the internet and I watched this thing about cancer and I learned about how it all starts with a clerical error, because nobody else besides me calls it that. Okay, like I said, we're putting this into layman's terms, so I'm going to use a lot of analogies and things, and it's not really a clerical error. There's very scientific terms for these things, but there are two big steps that have to happen before you get cancer. So the first one I liken to a clerical error. And it starts with a cell in your body, somewhere in your body. I'm going to draw, let me use a different color here. I'm going to draw a cell. We're going to pretend like this nice circle is a cell here. And I'm going to draw some squigglies because each cell has an instruction manual inside it. And those squigglies are going to be representative of my instruction manual. Now what happens is this cell does what almost all cells in your body do. It decides, hey, it's time for me to reproduce. Cells do that by dividing. And so this cell here, it's going to divide itself into two. And then when it does that, each of the two cells has to have an instruction manual. Now, I keep talking about this instruction manual. Each cell has to have an instruction manual inside of it that has instructions for every single thing a cell might need to do. So in order for this second new cell to have an instruction manual, this one has to make a copy of its instruction manual, right? Now, this instruction manual, you may have an idea what the real name for that instruction manual is. It's called DNA. So everybody's heard of this instruction manual, but because I'm using analogies here, I'm gonna stick with calling this an instruction manual for now, and you'll see why. Okay, so I've got these two cells here. So this original cell has got to make a copy of the whole instruction manual, right? Okay, so what happens is this clerical error happens. Now, why do I call this a clerical error? Because inside these instructions, like I said, there's instructions for everything, right? It also has instructions for copying itself, okay? It has an instruction that says start, here's how you copy, and then you stop copying yourself, okay? But a problem happens. That stop message is missing, or something's wrong with the message, or something happens and there's an error. There's this clerical error that makes it so that that message isn't transmitted here. And so this purple cell, I don't know if you can tell that's purple, but this cell doesn't correctly get that message copied into its new copy of its very own instruction manual. It gets a set of instructions copied that doesn't have a stop message. So this new cell has an instruction manual in it, and it has all these instructions, and it has instructions for how to copy itself, and it has instructions for how to start copying and keep copying, but there's no stop instruction. Why does that happen? We'll come back to that. But, so here's a cell. It has instructions to copy itself, no stop. So what does it do? It keeps on going. It keeps on copying and copying and copying itself over and over and over and over again, right? And all of these cells, they're going to have these same instruction manuals that are also missing a stop signal. So all of them are going to keep on going over and over and over again. Okay, so now if you remember our definition of what cancer is, right? We said it was a group of cells that are rapidly dividing out of control. So you might think at this point someone has cancer, but this person who has this happening inside their body doesn't have cancer yet, because this is just step one of the two-step process, okay? Step one's the clerical error. Now let's talk about step two. Okay, so step two is what I like to call a security failure. I don't know if y'all can even read my writing at all, but maybe you can. Anyway, I call it a security failure. Again, Christina term, not an official term. All right, why do I call it a security failure? Well, we have a security system within our body. And it's called the immune system. There are cells in your body that are constantly just traveling around the body looking for trouble. They're looking for things like bacteria, germs that come in from outside the body so they can get rid of those. But they're also looking for cells like this. They're looking for your cells that have gone rogue, that are doing things that they're not supposed to do. So, if all is well, your security system, your immune system, has cells that should come along, and they should see these cells that are just dividing and dividing out of control, and they should say, none of that, this should not be happening, you are forbidden. And they should come in here, and they should destroy these cells. The body will clear off these destroyed cells. You're done. You don't have cancer, you didn't even know any of that was happening, and you go on about your life. That's what happens if everything goes as planned, as it should. However, in someone that gets cancer, like I said, there is a security failure. I didn't even write a 2 there, did I? It's a security failure is your second step. Because for some reason, why? Here again, we'll come back to that. For some reason, these cells that are supposed to come on by and stop these rogue cells, they don't do it. They come on by and they just say, carry on. And they don't do anything about it. They let them keep on dividing and dividing and dividing. And now you have that out of control part of the cancer definition, because nothing is stopping them. And when your immune system lets these cells go and lets them have their way, that's when you've got cancer. That's when you got a problem. So you've got a two-step mechanism here. You have a clerical error of sorts. Again, I'm using an analogy here. I'm likening it to a clerical error where you have a cell that gets a copied message or copied instruction manual with a flawed message, and it starts copying itself over and over and over again and doesn't know that it's supposed to stop. And then you have a security failure where your immune system fails to recognize that there's a problem and you have rogue cells here, and it lets them keep on doing their thing and being out of control. Those are the two things that give you cancer. So now the next question is, and this is what everybody wants to know, how do you get cancer? We'll talk about that next. Okay, I had to stop and I rewrote this because I'm learning that I'm terrible at writing on whiteboards. So this still isn't great, but at least maybe you can see my two little things here. So back to what causes cancer. Now, I know that you're wanting me to say it's this that causes cancer. Sorry, can't tell you that. Now, I can tell you some things that cause cancer and give you some ideas. Now, but let's stop and think about it this way. Given what we've talked about, that to get cancer, you have to have 1, a clerical error, and 2, a security failure. What kind of things would you think would cause cancer? Now, first, let me take a step back and say this. Anyone who gets cancer, it's probably not going to be one thing that gave them cancer. It is unlikely that they walked outside and got one ray of sunlight that gave them melanoma. It's probably going to be multifactorial, meaning a combination of things happened to give them cancer. But that being said, the clerical error. What made this happen? What made this cell start dividing over and over again out of control? Now, I said I was going to stick to calling your DNA an instruction manual, and I did that for a reason. Because when I'm likening the DNA to an instruction manual, I want to keep talking about that, and I'm going to pretend like, of course, if you have an instruction manual, you've got a whole bunch of words inside it, right? So imagine that, you've got words, and if it's telling you instructions and you're reading an instruction manual, what happens if some of those words are missing, or some of those words are misspelled, or they're not in the right order? You're not going to get your instructions right, correct? So in DNA world, or DNA language, if you have missing words or jumbled up words or words that are out of order, those are called mutations. And mutations can happen a couple of ways. One way is DNA can get damaged. Now, imagine if your manual was not written on paper, but instead somebody had written out an entire manual in, remember those refrigerator magnets, the alphabet? Imagine if somebody had written out an entire manual in those refrigerator magnets so that they could get all mixed up and jumbled around. It's kind of how it is with DNA. So the DNA words, so to speak, of course there aren't really DNA words, but we're going to call them that. It's something like that. It's a code. Can get moved around. They can get deleted, they can get shuffled, they can get jumbled. So, if damage happens to that cell and that DNA or your instruction manual is damaged, those instructions can get damaged. And that's when you get what we call a mutation. Okay, so what causes mutations? Now, when I say what causes mutations, I mean, we're still talking about assuming you're getting it because you're getting damage. So that's when we start talking about things that everybody argues about, chemicals and things. Oh, that'll give you cancer if you eat it or drink it or whatever. There are things that we know have a high likelihood to give you cancer if you are exposed to them often. Those things we call carcinogens. Those are things that the government has tested, and they know from testing that if you are exposed to them, you have a very high likelihood to get cancer. And when the government tests something and there is a high likelihood and they see that most people that are exposed, or a lot of people, not most, but a lot of people that are exposed to get cancer, they pull that off the market, they pull it out of the public arena, they make it so that we are not going to be around that. That is officially a carcinogen. But there are a lot of other things that we don't know. People swear, oh, that causes cancer, but we haven't been able to prove it. It's more like a correlation, and some people think it does, some people think it doesn't. Who knows? We're not really sure. There are a lot of things like that. So there are chemicals, there are things that, people suspect cause damage. There's, of course, sunlight. We know that does damage to your cells. Smoking. If you know somebody that smokes, you know they don't just smoke those cancer sticks, as we call them in the cancer world. They don't just smoke those things once a day. They smoke them a bunch of times a day. And so they are hitting those lung cells and also other cells in their body, because those toxins are distributed throughout their body with those toxins multiple times throughout the day, over and over and over again. So they are just hitting those cells and doing damage to those cells over and over again. That's one of the reasons why smoking is one of those things that gives you the highest risk that we know of getting cancer. So these are the kinds of things that, we know give you cancer, but we don't know of anything that if you are exposed to it, you will, without a doubt, get cancer. Not a single thing. Not even radiation. Even people that have been exposed to radiation, if you live long enough, say the Chernobyl accident, everyone who was exposed to radiation after that accident didn't get cancer. A large percentage of them did, but not all of them did. We'll come back to that in a second, because I've got an interesting point about that here. But, there's nothing we know of that will definitely give you cancer. Not a single thing. Why? Because the human body has backups in place. The human body within your cells can recognize, they're little sentry-like things. That's not the official name for them. Again, I'm using an analogy. It's a sentry-like thing in your cells that are in there that can see and recognize when there are errors that happen, when that copying is happening, when the clerical stuff is happening, and they can see if a mistake is made, and they can go in there and fix it right there on the spot. There's all kinds of backups in here. Your body is an amazing, amazing thing. So there's all kinds of fail-safes, backups, things like that. Your immune system is amazing too. So we don't know of anything that will absolutely, positively give every single person, without a shadow of a doubt, cancer if they're exposed to it. I'm sure there's something out there. We just don't know what it is yet. I'm sure there's definitely things that will kill you, but as far as definitely getting you cancer without a shadow of a doubt, all the time, every single person, we don't know of anything. But there are plenty of things that will almost likely give you cancer. Smoking is one of those ones that gives you the highest risk of it. So anyway, so that's what would cause a mutation. What would cause a mutation that would cause this problem and this process, this clerical error to happen. Now, how about, you've heard plenty of people say cancer runs in my family. How does that happen? Well, that's typically when you inherit a mutation or a misspelling or something of that nature in your instruction manual from your family that makes it more likely for this process to happen. And I'm sure you've heard of things like that in the news media. The BRCA gene for breast cancer is a very well-known one. If you haven't, ignore that I said that. But you can inherit genetic mutations from your family members that make it more likely for this clerical error to happen. So that's how you get that whole, it runs in my family kind of thing. Now, I want to stop here and say something on the side. You're going to hear more and more about genetic testing of cancer. Now, it's not because they think everybody who has cancer that they inherited in some way, shape, or form from family members. It's because, let's look back at this process, every single person that has cancer has a genetic flaw in those cancer cells. Does not mean that they inherited that from someone in their family, but the genes, the DNA that is in those cells, that instruction manual has a problem. It has a flaw in it. That is why it is cancer. Remember, it started out as a normal human cell in that person's body, and the way it became cancer is it got a mutation somehow. It became mutated, and then that mutation caused this clerical error to occur. So there's a genetic flaw in every cancer cell. So these days, we are more and more often doing genetic tests on those tumor cells. We're not doing genetic tests on your whole DNA. We're not running a test to sequence your genome, which I think is what some people kind of think that we're doing when we want to do genetic tests on you. No. We don't have time for all that. We're not doing all that kind of stuff. We're just looking at the genes in the tumor cells to see what the problem is in the tumor cell, because certain drugs will target the problems with the mutations in those tumor cells. That's why we want to know what the genetic mutation is in that tumor cell. We can target those particular mutations, and we're getting better at that. That's why we want to do genetic testing on those tumor cells. So when you hear people and you hear all this stuff about they want to do genetic testing on me, why do they want to do that? We're not trying to sequence your genome. We don't want to know what color your eyes are or anything like that, or who your mom was or who your dad was. None of that stuff. That's not what we're looking at. We need to look at the DNA of the tumor cells. That's what we need to look at. Now, sometimes, on rare occasions, there might be a case where we might want to look at something, and that's rare, in an inherited case. And if that's the case, they're going to talk to you about it in your family. If you have a predisposition or a certain syndrome, there's some syndromes that are associated with getting cancer. That's a whole different thing. But when we talk about genetic testing on tumors, we're talking about looking for the mutation in those tumor cells. So, moving on from that little sidebar. So, we just talked about mutations from carcinogens, aka toxins, and we've talked about inheriting your cancer. What else could we have that could cause a problem up here? We could have viruses. I'm sure you've heard of HPV, right? So what would a virus do? Viruses can, just like chemicals, viruses can do damage to the instruction manual. They can mix up your instructions just like anything else can that's doing damage. So same thing there. Now, what about, you've probably heard people say cancer is a disease of the aged or a disease of aging. Now, this one's a little different. This one has more to do with step 2. This one has more to do with your security failure, because the older you get, the less well your immune system works. And so, like I said, all of us have this process happen, but typically your immune system is going to come along, see these guys, and wipe them out. As you get older, it's less likely that your immune system is going to be on its game, is going to really come along and recognize these guys and take them out. And so that's why you see more and more people that are older getting cancer, because their immune system just doesn't work as well. And the weaker the immune system, the more likely you are to get cancer, for that simple reason. You have 2 steps in this process. And when you make step 2 likely, that's half of the whole thing right there. So that is a big, big part of why cancer is a disease of aging. If you live long enough, you have a pretty good chance of getting cancer, because eventually, that immune system one day is going to miss this. And that's generally the idea behind why we think cancer is a disease of aging. Now, there's some other molecular ideas behind DNA replication in aging, but we're not going to go there. The general idea is your immune system. Now, that being said, guess what? Any other problems with your immune system can cause you to maybe not necessarily, I don't know if you really want to call it getting cancer, because you still have to have this process right here start. You still have to have the clerical error. But if you have a compromised immune system from some other disease, or even just stress, or anything like that, then you can have the security failure. And now here's the other thing. The more and more we learn about tumor cells or cancer cells, when they start dividing, they become less and less normal. They take on other characteristics. And we're starting to find out that these little guys are sneaky. They are sneaky little things. We think that in some cases they may have ways to hide from our immune system. And as I'm recording this right now in 2020, in the COVID days, we haven't really figured out all the mechanisms of how this works. But we think they have an advantage. They have some ways to kind of evade our security system and kind of stay off of the radar. So it's not necessarily, we think it might not always be so much our fault, so to speak. It may not always be just that our immune system falls down on the job. It may be that these guys are a little smarter than we think. And they may be able to hide or take our security guys out even. We're still working on that. There's a lot there. There's a whole lot to it. And boy, is it complicated. But basically, there's still a security failure that happens. And it still is true that if you have a weak immune system, you're much more likely to get cancer. Absolutely, without a shadow of a doubt. So, but we do think there's a possibility that these cancer cells can also be a little sneaky and get an advantage over your immune system too. So we're working on there's a lot of research being done there now too. And I'm sure you've heard, it's all over the news now, the big hot topic in cancer treatment is immune therapy. Now, that is why immune therapy is real big right now. It's because we're starting to realize that this security failure, if we could fix this, could take care of the whole problem. You know, because up until now, up until relatively recently, most of our cancer treatments have been just going after killing these cells. That's what we've been trying to do. And so now we're thinking, okay, well, we know, everybody knows chemotherapy ain't fun, and there are a good bit of side effects. We can control a lot of those side effects now, but it's rough. And we'll talk about that more in the cancer treatment video I'll do. But it'd be great if we didn't have to take any drugs that had side effects, right? So the idea, everybody's always been trying to think of how can we do this? How can we treat cancer without side effects? That would be perfect, right? So we started thinking, well, what if we can address this by going at it from another direction? What if we can fix the security failure? What if we can make the immune system do its job? What if we can make it go in there and fight off these cells like it's supposed to in the first place? That's the whole idea behind immune therapy. I'm going to go into that in a lot more detail when I go into explaining different types of chemotherapy when I do the cancer treatment video. But that's why immune therapy is a really hot topic right now. There's a lot of commercials on TV for several of the newest immune treatments that have been approved by the FDA right now. And they are things that are trying to get your immune system to work and trying to fix mutations and things that cause problems with your immune system. So that is it for this first video. I hope that made some sense and explained a few things to you, maybe told you a thing or two you didn't know about cancer. Again, please do remember I was speaking largely in analogies. I used very few actual correct scientific terms there, so take that with a grain of salt. But hopefully you got some big picture ideas and it made a little bit of sense to you. Check out my other videos. There's more to come, and I will see you soon. Thanks.